Hey, Damien and Jay, I wanted to make a video letting you know what we did today and kind of taking you through some things. So this is a little bit longer video, but it takes the place of you being in class. And I am expecting that you complete all the activities that we completed. So you need to make sure that you are logged into Amplify. But before you do that, let me take you through what our objectives and stuff are for today. So you are going to compose an answer to the investigation question using descriptions at the molecular scale, okay? We are going to be in Amplify 1.5. We're going to complete all the activities, and you do have homework today. So if I were you, I would go ahead and go to your assignment notebook. I want you to write in your assignment for today. And that is, the name of the assignment is CR, which means chemical reactions, 2 samples at the atomic scale. So this is the name of the assignment that's in Schoology, and this is what you're going to turn it in. This is actually a worksheet. I might stop by and see if you guys want a paper copy. But if I don't get a chance to get into the library, there is it's a PDF. It's in this folder, and then I want you guys to study the vocabulary and key concepts for 5 minutes. So as you are, go ahead and continue to play this video and take out your assignment notebook. And when you get there, you're going to write in, here's the name again, CR, 2 samples at the atomic scale. And it is this worksheet. You're going to go ahead and copy this into GoodNotes. And I'll explain how to do this in a second, okay? So if you need to pause the video so that you can get all that caught up, then go ahead and do that. Okay, let's go ahead and go into Amplify. And we are in lesson 1.5. So if I were you, I would do can you listen to this video and open up Amplify? I think you can. I don't think you have to close out of YouTube. If you have to close out of YouTube, don't. Go ahead and just do a split screen so you can continue to listen to the video while you're working in Amplify. Open up lesson 1.5. And then obviously as I'm talking, if you guys need to pause it so that you can get caught up or do what you need to do, then do that, okay? I'm going to have you guys start up with a warm-up. And the warm-up says 2 of the samples you observed during a previous lesson are shown below with a group of atoms that repeat to make each sample. Take a look at the samples and the groups of atoms using the atom key as a guide, and then answer the question below. So we've got 2 samples, sample 1 and sample 2. The repeating group of atoms that make up this sample 1 is K and Cl. And if I look down here in my atom key, I see that the purple K stands for potassium and the green Cl stands for chlorine. So the 2 atoms that make up this group are potassium and chlorine. And then if I look over here, I can see the repeating group of atoms. I've got a lighter purple, that's Na, which is sodium, and Cl, so that's chlorine. Okay, so based on this information, do you think samples 1 and 2 share all the same properties? Go ahead and click your answer. And I'm hoping that you said no, they don't share the same properties. Now the interesting thing is, if you remember, this would be sample 2 and sample 3 that we looked at a couple days ago. These were the ones that we described as being white, originally, white, small grain, solid, the small or the fine grain, solid. So just using our eyes, they look really similar, but we can see here that no, they are not the same. And I want you to kind of explain your answer below. So go ahead and pause this and explain your answer. And I kind of don't want to tell you the answer. I want to see where your thought process is, okay? So explain why, based on this atomic information, why are samples 1 and 2, why would they not share all the same properties? Go ahead and pause the video, fill this out, and hand it in. Okay, I'm going to jump back up here, and basically I'm going through my slideshow presentation for you guys. We observed that these substances have similar properties, but their atoms are too small to see. The diagram that we looked at shows us that the substances are in fact made of different types of atoms. And so that's why we know that they cannot share all the same properties, because they're not made from the same atoms. Okay? Atoms, this is a new vocabulary word. Atoms are the tiny pieces that all matter, in other words, all the stuff in the world is made of. We also talked yesterday about what substance is. Substance is something that's made up of all the same atoms or groups of atoms. So anything that is made up of atoms, in other words, everything in the entire world, can be referred to as a substance. So orange juice is a substance. Shoot, your table and chairs are made up of a substance. Anything that's made up of the same atoms or groups of atoms. A substance is a type of material that's made up of all the same atoms or groups of atoms. And we can think about substances in the way that chemists do in terms of atoms. So when we're looking at this substance, it's obviously water. We don't want to call it water, we want to call it a substance, and that's because it's made of atoms. And then just a reminder that we are going to be using the word model quite a lot, and this is a repeat vocab word. A model is an object diagram or computer program that helps us understand something by making it simpler and easier to see. Scientists often use models to learn about things that are too small to see. For example, we've worked with models to learn about small things such as molecules, but we really can't see atoms because they're too small. But atomic scale models, like the ones that we saw in the warm-up, can show the atoms that make up a substance. We have a new key concept. So I'm going to read this, and then you guys go ahead and pause it and write it down. Your key concept number 2 is a repeat. We've had this one, I think, twice already this year. And that is just to remind you that things that are too small or too large can be seen. Things that are too small or too large to be seen or to see can be studied with models. Sorry, I screwed that up. Things that are too small or too large to see can be studied with models. All right, go ahead and write that down in your key concept graphic organizer. That's in Good Notes, and it should be under your chemical reactions folder. So go ahead and pause the video and write this down. All right, let's keep going. In this unit, we're going to be using the chemical reaction simulation. It's a scientific model that shows the atoms present and how those atoms are grouped together in different substances. So today you guys are going to explore the sim in the chemical stockroom mode. This is really important. Look, it's called chemical stockroom mode, and you can select this mode using the menu. Let me show you what I mean. We're going to jump into Amplify, and if you go over into activity number 2, it's the investigating substances in the sim. Look at the second page, and we've got this chemical reaction simulation. Now I'm going to let the kids just kind of mess around in this simulation, like how I do every time we have a brand new simulation. It's fun for you guys to just kind of explore it. But this is what I want to make sure you do. Look at the 3 lines up here in the top right. When you click on that, you're going to see this chemical stockroom mode. It automatically defaults to laboratory A. I do not want you to use that today. It'll be really difficult. You're not going to understand what you're doing in laboratory A or B. So go up in chemical stockroom, click that, and then I just want you to mess around for a little bit. You're going to notice that we've got atoms and their compound name over here, and it scrolls down. There's quite a lot. You are able to click on a maximum of 3 to look at. And as you're messing around with these, I want you guys to notice that we've got the chemical formula. And remember, all the elements, the symbols of the elements, when it's a capital letter, that means it's the start of an element. And then if it does have a second letter, it'll be lowercase. So in this case, we've got 2 different atoms that make this up. We've got aluminum and we've got bromine. And there are 3 atoms of bromine. So you can see that in the element, or in the chemical, the molecular model right here. You can bend it because it's a solid. And here I've got the phase that it is. It's a solid. The color, some of these properties, it's light brown, it's odorless, the melting and boiling point are right here. And this is kind of cool. It kind of shows you what it is. So sometimes a solid is like a rock, sometimes a solid is a powder, sometimes a solid is granule. And we can see when I bend it, it actually separates. So this would be granular, all right? Let's just, for kicks and giggles, I'm going to get rid of one of these, and I'm just going to go to straight. I'm going to look at just straight carbon. Carbon in its own, like pure carbon, is just made up of repeating atom groups of carbon. So it looks just like this. It's carbon, carbon, carbon. This is what's called a pure element. If I bend it, it separates because you can break carbon apart. All right? Sometimes bending, I don't know if I've even done it. You can click on these bending for the solids and it does not separate. And you'll see what I mean when you look at them. Sometimes you'll see that it's not a solid, it's a liquid. Sometimes it's a gas. And I'm just going to let you guys play around with that for a couple minutes. So go ahead and pause the video, and then I want you to mess around with it and come on back when you're ready to get started and finish, okay? All right, so now that you've messed around in your lab, or in the computer simulation, we're going to continue on. So we know that different substances have different properties. To understand why, we're going to use the sim to investigate different samples at two scales. We're going to look at the macro scale and the atomic scale. So these are atomic scales models of 3 different samples. This is sample number 1. This is sample number 2. This is sample number 3. You're going to observe and discuss these models and partners, and actually you guys are going to have to do it on your own, in order to make a claim about whether they represent the same or different substances. So I'm trying to find out, is sample 1 the same or different than any of these? Is sample 2 the same or different than these? Is sample 3 the same or different than these? And then you're going to use the sim to gather more evidence, okay? So after you choose a claim, I want you to test your hypothesis. And I'll keep the samples displayed here so you can make a comparison. Maybe what you guys might want to do is just take a screenshot of this. Go ahead and do that so you have it. And then that way you can refer back to it whenever you want to. In class, I'm going to just leave this slide displayed for the kids while they're working in the sim. Okay, so this is activity 2, screen 3. So we're going to come back in, and we're still in activity 2, and scroll down to screen 3. Well, I guess you guys have you've got the card that has that on there, so you don't need that. Okay, so based on the atomic scale models of the sim, which of the following claims do you think is best? Claim number 1, all 3 samples have the same properties, therefore they're the same substance. So you're going to have to go into the chemical reaction simulation, and you're going to have to read down. Remember when it talked about the different properties like the color, the boiling point, the melting point? You're going to have to go in and see, do they have the same properties? Okay, if they do have the same properties, then you can go ahead and click claim number 1. Claim number 2 says 2 samples have the same properties, therefore they are the same substance. However, 1 sample has a different set of properties, therefore this sample is a different substance. And claim number 3 says all 3 samples have different properties, therefore they are different substances. So you're going to go ahead and launch the chemical reaction simulator. And I think I will go ahead and do that for you. You guys do it. I'm going to keep the directions here. So you guys are going to go ahead and go into the simulator, and I'll keep the directions here, and I'll tell you what to do. I'll be your partner today, okay? So the atomic scale models are displayed. They're right here, and I'll let you guys keep looking at those. And then you need to find the substances represented by these models in the chemical stockroom mode of the sim. Okay, so I'm going to keep this here. You guys are in your chemical reactions simulation. Now, can you find sample 1? It's got oxygen, carbon, oxygen. Just a reminder, make sure that you are in the stockroom mode. And you are looking for oxygen, carbon, oxygen. And there it is. Oxygen, carbon, oxygen. So go ahead and click on that. And then sample number 2 is just one atom of carbon and one atom of oxygen. And so you can find it right here. This sample is called carbon dioxide because it's got 2 oxygen. This one is carbon monoxide. And then this right here, sample number 3, interestingly enough, if you look at it carefully, I've got this repeating group and this repeating group. Because these are not connected, I'm not looking for carbon, oxygen, carbon, oxygen. I'm looking for carbon, oxygen. And then another carbon, oxygen, which we found right here. Okay, so let's take a look and compare these properties. First of all, carbon dioxide, I can compress it because it's a gas. Okay, so we can compress it. Can we compress carbon monoxide? And the answer is yes, we can, because it is also a gas. Let's compare it. It's colorless, so is this one. It's gas, so is this one. It's odorless. This one's odorless as well. Here's where we've got some differences. The melting point and boiling point are both at negative 78 degrees Celsius for carbon dioxide. Carbon monoxide, melting point is negative 205 degrees Celsius. Boiling point is negative 192 degrees Celsius. So we do not share the same properties. So when you come back here to amplify to the curriculum, we can go ahead and say claim number 2 is right. 2 of the samples have the same properties. I'm going to remind you again, sample 1 and sample 2 do not have the same properties. We see that here. We've got sample 1 and sample 2. The hang up is right here with sample 3. Basically what I've done is I've taken sample number 2 and I've just added another molecule of carbon monoxide, and I've got 2 molecules of carbon monoxide. So sample 2 and sample 3 are the same. They do share the same properties, but sample number 1, carbon dioxide, is completely different. So it does not. So we would go ahead and click on claim number 2. And then does the evidence from the sim support the claim that you choose? Yes, it does. And what evidence did we find in the sim to support your answer? I would say carbon monoxide and carbon dioxide do not have the same melting point and boiling point. And that's the reason why they that's the reason why I know that they are not the same, and they're different substances. Okay. Carbon monoxide and carbon dioxide do not have, sorry you guys, the same melting point and boiling point. Based on my observation in the sim, I think sample 1 is a different substance with different properties than sample 2. Okay, sample 1 is different than sample 2. I think that sample 1 is a different substance with different properties than sample 3. So there's sample 1 that's different than sample 3. And then lastly, sample 2 is the same substance with the same properties as sample 3. Again, I've got 1 molecule of carbon monoxide and I've got 2 molecules of carbon monoxide. So these, sample 2 and sample 3, are totally the same. I just have more of them here in sample 3. When you are finished with this, make sure that you hand that in. Okay? Go ahead and pause that and do what you need to do. Okay, let's keep going. We need to talk about the article, Atomic Zoom In. I'm going to have the kids reread a section of the article in order to gather more evidence. Starting on page 1, so you guys should have hard copies of this. Go ahead and pause this and get your articles out. Okay, so take a look on page 1, and I've highlighted the section I want you to start off. I want you to reread the section, how atoms make your orange juice smell good and your socks smell bad. And this actually takes up this little section and then all of page 2 and some of page 3. Go ahead and reread that and be sure to pay attention to the text, the diagram, and the caption. And we're trying to find out, remember, we're trying to gather more evidence about why different substances have different properties. Go ahead and take a second look at that and make more annotations if you need to. Pause this video. Okay, once you have looked through that again, you guys are going to, let's try and answer this first investigated question. Why do different substances have different properties? Well, we know that we've got different numbers of atoms that repeat to make up a substance. And it's said in the article on page 2, and actually let me do this really quickly. I'm going to pull up, oh bummer, I might have gotten rid of this. Let me try something really quickly, I'm sorry. I'm going to pull up the article real quick so you guys can see what I'm showing everybody. So here's your article, and I wanted to show you on page 2, this ethyl butyrate is a naturally occurring substance. And if you look carefully, we do see that it has some chemical or some physical properties. It is a clear liquid, and it does have a strong smell of pineapple and orange. Okay? The chemical formula is C6H12O2, which means that there are 12 hydrogen, and if you guys would count those, you would see there are 12 of them. There are 6 carbon atoms, so 1, 2, 3, 4, 5, 6, and there are 2 oxygens. So the way that the number of the number of atoms makes a difference, and the way those atoms are arranged makes a difference. That's what makes this uniquely ethyl butyrate. It can't be anything else because of the way that it's organized. So we compare that to another, this is called a compound, another compound that has a mixture of different atoms put together, and we're comparing that to something called isovaleric acid. Isovaleric acid. This is also a colorless liquid, but it doesn't smell like pineapples or oranges. It smells like sweaty gym socks, which is really gross. So why are they different? They both are made of hydrogen, oxygen, and carbon. Well, the difference is that isovaleric acid has a different chemical formula. Instead of 6 molecules of carbon, we only have 5. 1, 2, 3, 4, 5. And instead of 12 hydrogen atoms, we only have 10. They still have 2 oxygen, but because of the different number of atoms, involved in this molecule, it's different and it has different properties. So if we look at key concept number 1, it says different substances have different properties. Why? Because they're made of different atoms. And not only are they made of different atoms, but the atoms are arranged totally differently. Really pay attention here. In the ethyl butyrate, the carbons are kind of in a line right here. And we have this one oxygen that's in between these 2 carbons, right? Well, look over here. The carbons are kind of bunched up right here. And my oxygens come off the 2 different carbon, or the 1 different carbon here. I've got 2 oxygens. And then instead of a carbon coming off of this oxygen, I have another hydrogen coming off of it. So there's 2 parts to that to answer that question. Number 1, different properties or different substances have different properties because different atoms are used to make up those substances. And then number 2, they're arranged differently. Let's go ahead and take a look at my slideshow here. As we saw in the video, everything is made of atoms. Atoms and the groups they form are what give each substance its unique set of properties. So now that we've answered question number 1, let's go ahead and go down to question number 2. It's really, really important that you guys understand the difference between an atom and a molecule. And in fact, there's a third word I want to use. So an atom is the individual element. It's just one of those elements. So oxygen, carbon, chlorine, whatever. It's one. A molecule, technically, is when I have a grouping of the same one. So let's say these are oxygen. This would be oxygen, this would be oxygen. This is chlorine, this is chlorine, this is chlorine. This is, let's say, carbon, this is carbon, okay? So a molecule is 2 or more of the same element chemically bonded in a fixed ratio. So there's always 2, right? Then we have this third word. This is called a compound. A compound consists of 2 or more elements. So this is the same element chemically combined. A compound is 2 different elements chemically combined, 2 or more. So this would be like if we had H2O, hydrogen and 2 oxygens, or this is NaCl, so sodium and chlorine. That's a compound. So these are words that we're going to be using quite a lot. Make sure that you know the difference. Atoms, molecules, compounds. All right, different substances have different properties because they're made of different repeating groups of atoms. Water is made of this repeating group of atoms, 2 hydrogen, 1 oxygen, over and over and over and over again. All of those together collectively make water. And believe it or not, this is one compound for oil. This is vegetable oil. Isn't that crazy? Look at how many. These are carbons and hydrogens. The hydrogens are white, the carbons are black, and then I have just a few oxygens over here. Isn't that crazy? That is one compound for oil, and you have to have all of those combined, like hundreds of thousands of millions of them, billions of them to make oil that we see. Here's your homework. It's activity number 4. So go ahead and go into activity number 4. I have it, like I said, I've got that paper copy. I had you go ahead and put this into GoodNotes. It might be a better idea that you guys have it in GoodNotes so that you can use colors. You're going to use a modeling tool to create an atomic scale model of sample number 2, which is this right here, just like the models that you observed in the sim, okay? Let me kind of explain something. For this activity, you're going to use information about 2 samples to create an atomic scale model using the modeling tool. Let's take a look at a diagram that shows the different ways that atoms and groups of atoms repeat to make up a substance. So first of all, we have this. This is gold, and this is what's considered a pure substance because this is just one single atom and it repeats. So gold is a repeating group of atoms of just pure gold. So it repeats over and over and over again. NaCl is sodium chloride, and this is another word for, it's table salt. It's what we use when we cook. And this repeating group of atom only repeats, and it uses 2 atoms. This is what we would call a compound. And you can see that it's always 1 sodium, 1 chlorine. 1 sodium, 1 chlorine, 1 sodium, 1 chlorine. And I want you to notice the way that this kind of connects together. The sodium and the chlorine are always touching each other. So the chlorine never touches itself. But look at how all these atoms are touching each other. Same with the gold. They always touch each other. Now, this is a molecule. A molecule is, technically, this is a molecule. This is a compound. But when I have one grouping right here, that is a molecule. It's a compound. And what that means is water is always H2O. This means that I have 2 molecules of water. Okay? 2 molecules of water. Do you notice that the molecule, the atoms have to touch itself? Okay, they're always together, they're always touching. If I have any space in between the repeating patterns, then I know that I have more than one repeating pattern, like more than one of those compounds. Does that make sense? I hope it does. So let's keep going. You guys are going to, let me go through this really fast. Here we go. Let's do the homework. So it says Dr. Yoon, in her lab, Dr. Yoon has 2 samples that are both made up of hydrogen and carbon atoms. So they both have hydrogen and carbon together. Some of the properties of each sample are listed below. A model of the group of atoms that repeats to make up sample number 1 is also shown below. I want you to use the modeling tool, 2 samples at the atomic scale, student sheet, to create a model that represents a repeating group of atoms that could make up sample 2. Here's the thing. We don't know what that looks like. There could be, and there really are literally a dozen different ways you can do this. There's no technically right answer, only that you have to use hydrogen and carbon. Okay, so let's follow the instructions. It says draw a possible atomic scale model for sample number 2. And I want you to go ahead and use this coloring tool. So before you start drawing your sample here, let me go through and let's check this out. Sample number 1 is made of hydrogen and carbon. The smell is odorless. It boils at negative 164 degrees Celsius, and it looks like colorless gas. So that's what this looks like. You notice that nowhere here where it doesn't tell me at all how many hydrogen and how many carbon I have. And that's okay. The reason for that is because they just kind of want to make sure that you're understanding the structure of a molecule and that the atoms have to touch. Okay? So we've got 4 hydrogen and 1 carbon. If I come over here to my color key, the hydrogen is going to stay white, so don't do anything with that. But the carbon is black. So on your worksheet, I want you to make sure that you color this carbon atom black. Okay? In fact, why don't you pause the video and go ahead and do that now? Okay. Now it's your turn to try and come up with what you think a molecule of this sample number 2 is. There's no name. There's no, like, you're not going to go back into the sim and find it. This is really general on purpose. This is made of hydrogen and carbon, so you have to have at least 1 hydrogen and 1 carbon, but you could have like 5 hydrogen and 3 carbon. We don't have numbers, so you can make it up, whatever you want to do. The smell is similar to gasoline. It boils at 36 degrees Celsius, and it looks like a colorless liquid. Now, all of this is just to show you that it's totally different than this one. So you're not going to repeat this pattern. That would be the only thing that you would do that was wrong. Do not put 4 hydrogen and 1 carbon over here and make it similar, because they do not have similar properties. It can't be right. Go ahead and just draw what you think this atom would look, or what this molecule would look like. You, again, make sure that you have at least 1 hydrogen and 1 carbon, but you can make as many as you want. And make sure that all of the atoms are touching, okay? Let me know. You can email me. Let me know if you have any questions here. Once you're finished with that, you're going to turn that into Schoology, and the name of the assignment is going to be Chemical Reactions, CR, 2 samples at the atomic scale. So just look for this title here, okay? Let me go back and make sure I don't have anything else. Yep, that's it. That's the end of our lesson. I'll try and stop by during my plan period, second period, to see if you guys have any questions about this, okay? And so just write down your questions, and I'll stop by during second period. All right, you guys, I'll talk to you later. Bye-bye.